Download this code from codegive.com, link in the description below. Comprehensive tutorial, Parsing Json in Android with Retrofit. This tutorial provides a detailed guide on using Retrofit, a powerful type-safe HTTP client for Android and Java, to parse JSON data from a web API. We will cover setting up Retrofit, defining API interfaces, making network requests, handling responses, and dealing with potential errors. Prerequisites **** basic understanding of Android development and Java or Kotlin. * Android Studio installed. * emulator or physical Android device for testing. Table of contents * 1. Introduction to Retrofit. 2. Project setup. * adding dependencies. * enabling internet permission. 3. Defining data models, pojos/data classes. 4. Creating an API interface. 5. Building the Retrofit instance. 6. Making API calls. * using enqueue, for asynchronous requests. * using execute, for synchronous requests, not recommended for main thread. 7. Handling responses. * successful responses, status code 200 to 299. * error responses, status codes 400 plus. * handling network exceptions. 8. Configuration options. * customizing the base URL. * adding headers. * using converters, Json, Moshi, Json. * logging interceptors. 9. Advanced concepts. * path parameters. * query parameters. * form URL encoded. * multi-part requests, file uploads. * using call adapters, RxJava, coroutines. 10. Kotlin integration. 11. Best practices. 12. Complete example, Android and Kotlin. * build.gradle, module app. * Android manifest.xml. * data model, user.java/user.kt. API interface, apaservice.java/apaservice.kt. Retrofit instance, retrofitclient.java/retrofitclient.kt. mainActivity.java/mainActivity.kt. activity_main.xml. 1. Introduction to Retrofit. Retrofit simplifies the process of making network requests in Android. It acts as a type-safe REST client, allowing you to define API endpoints using interfaces and annotations. Retrofit automatically converts the API response, usually in JSON format, into Java objects, POJOs, plain old Java objects, or Kotlin data classes, making it easier to work with the data in your application. Key features ***. Type safety ** APIs are defined using interfaces, ensuring type correctness at compile time. Declarative * define API endpoints and request parameters using annotations. Automatic serialization/deserialization converts JSON to Java/Kotlin objects and vice versa. Extensibility supports different converters, Json, Moshi, Json, and call adapters, RxJava, coroutines. Ease of use reduces boilerplate code compared to using HTTP URL connection or HTTP client directly. 2. Project setup. 2.1 Adding dependencies. First, add the necessary retrofit dependencies to your build.gradle, module, app, file. *com squareup.retrofit to retrofit, the core retrofit library. *com_up.retrofit2 converter Json, a converter factory that uses Json to serialize and deserialize JSON. You can replace this with other converters like converter Moshi or converter Jackson if you prefer. *com_up.oket3 logging interceptor, an OK HTTP interceptor that logs HTTP requests and responses. This is extremely helpful for debugging. OKit dependency is required by Retrofit and this interceptor, but may be implicitly added by Retrofit. *org.jetbrains.codelinks codelinks coroutines core and org.jetbrains.codelinks codelinks coroutines Android for kotlin coroutines. *androidx.lifecycle lifecycle libdata.ktx, androidx.lifecycle lifecycle viewmodel ktx, and androidx.lifecycle lifecycle runtime ktx for kotlin viewmodel and libdata to update the UI based on the result. After adding the dependencies, sync your project with Gradle files, file-sync project with Gradle files. 2.2 Enabling Internet Permission. You need to request the internet permission in your Android manifest.xml file to allow your app to make network requests. Add this permission tag within the manifest tag of your Android manifest.xml file. 3. Defining data models, pojos/data classes. Create Java classes, pojos, or Kotlin data classes to represent the structure of the JSON data you'll be receiving from the API. These classes should have fields that match the JSON keys. Example JSON response, from a hypothetical user API. Java POJO, user.java. Kotlin data class, user.kt. Important asterisk the field names in your POJO/data class must match the JSON keys, case sensitive, or you'll need to use JSON's @serialized name annotation to map JSON keys to different field names. For instance, if the JSON key was user_ID, you'd use 4. Creating an API interface. Define an interface that describes the API endpoints you want to interact with. Use retrofit annotations to specify the HTTP method, get, post, put, delete, the endpoint URL, and any request parameters. Example API interface, apiservice.java. Kotlin, apiservice.kt. *@get, /todos, this annotation specifies that this method will make a GET request to the /todos endpoint, relative to the base URL. *call list user get users, the return type is call list user. Call is a retrofit class that represents an asynchronous API request. List user indicates that the API is expected to return a list of user objects. 5. Building the retrofit instance. Create a singleton class or a helper method to build the retrofit instance. This instance is responsible for creating implementations of your API interface. Java, retrofit client.java. Kotlin, retrofit client.kt. *base_URL, replace this with the base URL of your API. The base URL should end with a /. *JSON converter factory.create, this creates a converter factory that uses JSON to handle JSON serialization and deserialization. *HTTP logging interceptor, this is a very useful tool for debugging. It logs the details of the HTTP requests and responses, headers, body, etc., to the Android Studio console. You can set the log level to control the amount of information logged, example level.body logs everything. *OKHTTP client, the OKHTTP client is the underlying HTTP client used by Retrofit. You can configure it with interceptors, timeouts, caching, etc. 6. Making API calls. Now, you can use the Retrofit instance to create an implementation of your API interface and make API calls. 6.1 Using enqueue for asynchronous requests. This is the recommended approach for most cases, as it performs the network request off the main thread, preventing your UI from freezing. Java, main activity.java. Kotlin, main activity.kt. Asterisk retrofit client.getClient.create, apaservice.class, creates an implementation of the apaservice interface using the retrofit instance. Asterisk apaservice.getUsers, calls the getUsers method defined in the apaservice interface. This returns a call object. Asterisk call.enqueue, new callback list user. Asynchronously executes the request using enqueue. The callback interface provides two methods. Asterisk on response, call list user call, response list user response, called when the API request is successful, regardless of whether the response code is 200 to 299 or an error code. The response object contains the response data, status code, headers, etc. Asterisk on failure, call list user call, throwable T, called when the API request fails due to a network error, connection problem, or other exception. The T object contains the exception information. Asterisk response.is successful, checks if the response status code is in the range 200 to 299, indicating a successful request. Asterisk response.body, returns the deserialized response body as a list user, or null if the response body is empty. Asterisk response.code, returns the HTTP status code of the response, example 200, 404, 500. Asterisk t.getMessage, returns the error message of the exception. 6.2 Using execute, for synchronous requests, not recommended for main thread. Execute, performs the API request synchronously, blocking the current thread until the request completes. This is generally not recommended for the main thread because it will freeze the UI. If you need to use execute, perform the API call on a background thread, example using async task, executor service, or Kotlin coroutines. Java, illustrative example using async task, do not use this on the main thread directly. Kotlin, illustrative example using coroutines. Asterisk call.execute, synchronously executes the request. Asterisk the example uses async task, Java, and coroutine scope, dispatchers.io, .launch, Kotlin, to perform the execute, call on a background thread and then update the UI on the main thread using onPostExecute, Java, or with context, dispatchers.main, Kotlin. This prevents the UI from freezing. 7. Handling responses. Properly handling responses is crucial for a robust application. Consider these scenarios. 7.1 Successful responses, status code 200 to 299. Asterisk check response.is successful, to verify the status code. Asterisk retrieve the response body using response.body. The type of the response body will be the type you specified in the call object, example list user. Asterisk handle the data in your UI or other parts of your application. 7.2 Error responses, status codes 400 plus. Asterisk even if response.is successful, returns false, the API request might still have completed successfully on the network level, example the server returned a 404 not found error. Asterisk you can get the error code using response.code. Asterisk the error body might contain additional information about the error, Example: a JSON object with an error message. You can access the error body using response.errorbody, but you'll typically need to convert it into a string and then parse it as JSON. Asterisk: inform the user about the error appropriately. Example of handling error responses, Java. Kotlin asterisk. 7.3 Handling network exceptions. Asterisk: the onFailure method is called when the API request fails due to a network error, example: no internet connection, timeout, connection refused. Asterisk: the throwable object passed to onFailure contains information about the exception. You can get the error message using t.getMessage. Asterisk: inform the user about the network error. Consider providing a retry button. Example: Java. Kotlin asterisk. 8. Configuration options. Retrofit offers various configuration options to customize its behavior. 8.1 Customizing the base URL. The base URL is set when you build the Retrofit instance. Kotlin asterisk. 8.2 Adding headers. You can add static headers that are the same for every request, using an OKHTTP interceptor. You can also add dynamic headers that change per request, using annotations in your API interface. Static headers, using OKHTTP interceptor. Kotlin asterisk. Dynamic headers, using @header annotation. Kotlin asterisk. Then, when you call getUsers, you'll need to provide the auth token value. Kotlin asterisk. 8.3 Using converters, Json, Moshi, Json. Retrofit uses converter factories to handle the serialization and deserialization of data. Json is a common choice, but you can use other converters as well. Asterisk: Json, already shown in the examples. Add implementation com.squareup.retrofit to converter Json 2.9.0 and use Json converter factory.create. Asterisk: Moshi asterisk. Add implementation com.squareup.retrofit to converter Moshi 2.9.0 and use Moshi converter factory.create. Asterisk: Json asterisk. Add implementation com.squareup.retrofit to converter Json 2.9.0 and use Json converter factory.create. Example with Moshi asterisk. Kotlin asterisk. 8.4 Logging interceptors. Logging interceptors are invaluable for debugging. The most common is HTTP logging interceptor from OKHTTP. Kotlin asterisk. Asterisk level.none, no logging. Asterisk level.basic, logs the request method, URL, and response status code. Asterisk level.headers, logs the request and response headers. Asterisk level.body, logs the request and response headers and bodies. This is the most verbose and useful for debugging. 9. Advanced concepts. Retrofit supports a wide range of advanced features for building complex API interactions. 9.1 Path parameters. Path parameters are placeholders in the URL that are replaced with actual values. Kotlin asterisk. Kotlin. Import retrofit to .call. Import retrofit.